Okay, before we start, I'd like confirmation that you guys can hear me and see me, please. Okay, cool. Sorry for the delay. I just had some issues setting up the YouTube, but we are up and running. Okay, perfect. So, Assalamu alaikum and good morning to everyone. Welcome back to grade 8 mathematics by Inspired Teens. Hope that you guys had a good week rather of school. And for today's topic, we are going to be continuing with ratios. We're going to be ending on ratios and we are going to be getting into some finance. Okay. Perfect. Okay, and YouTube as well. Can you guys just confirm that you guys can hear me? Okay, cool. Okay, so last week, right, we finished up highest common factor, lowest common multiple, and then we did some ratio, simple conversions. We did increasing or decreasing in a given ratio, right, which proved to be simple by just utilizing that explanation. Okay, so now we're going to talk about ratio and sharing. Okay, so this is just a simple example. It says, if sweets are shared between you and your friend in the ratio 2:3, it means that for every 2 sweets that you get, your friend gets 3. So the total shared is 5. 2 plus 3 is equal to 5 parts. So yes, that's how we want to understand it, right? So again, if you're splitting something in a certain ratio, right, you need to understand that you're getting a certain part, they are getting a certain part, and when you add it together, you're getting the total parts, right? So just like this example, I'm just trying to think. A simple example is if you have 100 Rand between yourself and your sibling, and you have to split it in a 1-to-1 ratio, okay? Meaning when we are saying that you have to split it in a 1-to-1 ratio, the value that they get has to be equal to the value that you get, okay? And obviously you have to spend the entire 100 Rand. In that case, you would get 50 Rand each. Okay, so that in that case, you would say that this is split in a 1-to-1 ratio. Okay, just a simple explanation. Now let's do an example that's slightly more complicated. So it says, divide 30 sweets between Thabo and Jenny in the ratio 2:3. Okay, so yes, now in this case, it's not a 1-to-1. Okay, it depends. Maybe this number is not so difficult, so we can predict it. However, numbers can be high and it's not easy to predict, but then we follow the method, right? So now we need to remember, right, the rule that whichever name is mentioned first is for that ratio, is for the first ratio. Whichever name is mentioned second, it's for the second ratio, right? That's just general in maths. So in this case, we have Thabo and Jenny, okay, as a 2:3 ratio. Now, remember, Thabo needs to get 2 parts, Jenny needs to get 3 parts. So in total, there's 5 parts. So essentially, see if we can, because now we know if we have 5 parts, that makes it much easier, right? So just say we had 5 sweets. If we had 5 sweets, then we know that Thabo needs 2 parts and Jenny needs 3 parts. So in that case, we know Thabo would get 2 sweets and Jenny would get 3 sweets, right? So if we have 5 perfect parts, then it's simple to split it between Thabo and Jenny, right? 2 and 3. However, we have 30. Sorry. Okay, so we have 30 parts. So essentially what we need to do is we need to take 30 and divide it by 5 parts so that we know the value of 1 part. Thereafter, we can give Thabo 2 parts and Jenny 3 parts respectively. So we then say 30 divided by 15. Sorry, 30 divided by 5. And that gives us 6 sweets. Sorry. Okay, and that gives us 6 sweets. Okay, so now we know the value of 1 part. Okay, I'll show you 2 slightly different ways of approaching it. Both would be the same either way. Okay, so now we know the value of one part. So since I know the value of one part, I can take the value of one part, and for Thabo, let's just write T, right? I can say 2 times the value of one part, which is 6. So now I know that Thabo is going to get 12 sweets, right? For Jenny, I know that she needs 3 parts, and I know the value of one part, which is 6. All right, so I multiply Jenny's shares by 6, and I get 18 sweets. Okay, and you can confirm that when you add 12 and 18, you're going to get 30. So in that case, your splitting is correct. Another slightly alternative route you could take is, okay, you know that there are 5 parts. So 2 plus 3 tells us that, okay, these sweets were split in a total of 5 parts. Okay, so Thabo's portion is 2 over 5. So sorry, Thabo's portion is 2 parts, okay, and out of the total amount of portion, which is 5 portions, so we could express that as a fraction, and we could say that Thabo's parts are 2, total parts are 5, 2 over 5 times what? All right, so now we've expressed Thabo's ratio of sweets as a fraction. Thabo takes 2/5 of the entire sweet package, right? So it's 2 over 5 times 30, and that would give us 12 directly. And for Jenny, we know that she needs 3 parts. 3 parts out of how many in total? 5. So 3 over 5 times the total number of sweets, 30, and that's going to give us 18 sweets. Okay, cool. So that's basically splitting it into a ratio. Let's look at the next example and split this really quickly. 69 apples, okay, between 3 different animals on a farm in the ratio 15 to 5 to 3. Again, remember, keyword, okay, they don't mention it, but sometimes they do respectively. Even if they don't, you just assume horses because it's mentioned first, it's for the first, second, and third. So 69 is the total amount of apples. I'm going to take the second approach, I think maybe is a bit quicker, right, than this one, finding the value of one part and then multiplying it. So let's do the second method. Share 69 apples. Okay. So I need to know when I'm splitting it into these different parts, how much is the total amount of parts that I get? It's going to be 23 parts in total. So out of the 23 parts, horses are taking 15 out of the 23 parts. Now, remember, this is 15 out of 23. Our total is actually not 23. Our total is 69. So we're basically calculating what are 15 23rds of 69, okay? Expressing the horses share divided by the total amount of parts, okay, multiplied by the total amount of apples, okay? Now, in this case, when we do this calculation for the horses, we get 45 apples. Let's do this, guys. 5 over 23, right? So because they have 5 parts over the total amount, 23 parts multiplied by the total, and we get 15 apples. Okay, there's nothing wrong with calculating the value of each part first, if you'd like. Okay. Goats, 3 over 23 times 69. Nine apples, right? Okay, and of course you can double check by adding those 3 up, and when you do add them up, you get 69. That's just to double check that you have got the correct answer, because obviously in total all the apples need to add up to the total number of apples. If you want to do it the other way, basically you're going to say 69 divided by 23 parts. In that case, you're going to get an answer of 3. So it's 3 apples per part, basically, per share, if you'd like. Okay, and then of course, in that case, since you know that's 3 apples per part, for horses, you're going to say they have 15 parts or 15 shares. So 15 times 3, you'd say 5 times 3. And for goats, you'd say 3 times 3. And of course, you'll get the same answers. Okay, let's move on. Let's look at this example. It's a bit different. In a bag of marbles, there are blue and pink marbles in the ratio of 2:7. Okay. If there are 16 blue marbles, how many marbles are there in total? Okay. So in this case, they're asking it slightly different. They're asking us how many marbles are there in total. We don't have the amount of blue marbles. So you can express this beneath each other so that you understand it. So this is for blue to pink. So of course, blue is 2, pink is 7, right? So blue, okay, let's just do this. Blue is to pink, right? Is 2:7, okay? And we actually know, so remember, this is the simplest ratio, okay? So let's just pose another scenario where I have cows on a farm to sheep, okay? If I have 150 cows and 100 sheep, okay, in that specific case, right, I can simplify this as a 3:2 ratio, okay, in its simplest ratio. In its simplest ratio. Said, you're referring to number 2. Okay, in its simplest ratio, because I can actually divide them. Okay, I'll do. I can actually divide them by the the highest common factor. Okay, I'll go through the fractions again, no problem. Okay, I can simply divide them, right, by a common number, and I get 3, or even if you want to put in your calculator, you can say 150 over 100. It's going to give you 3/2. Okay, this statement is important. Remember, fractions are a common way of writing ratios. So 3:2 could also be written as 3/2. And in this case, it would be equal to 150 over 100. Right, I'm keeping the same ratio. I am maintaining the same ratio. So while I have 150 cows and 100 sheep, it's almost like for every 3 cows, I have 2 sheep. That's what the ratio represents. So when I simplify it and again, oh, what's my ratio of these animals? It's a 3:2 ratio. Okay. And remember, if I just have this information, right? Okay, wait, let's not go that route, but let's go back here, right? So when I have the information that it's the simplest ratio is 3/2, okay, in that case, when I look at the actual amount, I will see that they maintain the same ratio. So to go from 3 to 150, it was multiplied by 50. To go from 2 to 100, it was multiplied by 50. Okay, so similarly here we divided by 50 to simplify, and we divided by 50 to simplify, right? So as you can see, when we have the simplest ratio, right, the actual amount, okay, for whatever the quantity is, whatever the thing is that we have the ratio for, that actual amount will always maintain that same ratio. Okay, because here we are saying that the cows and sheep have a ratio of 3:2. So the total amount needs to maintain that same ratio, of course, when simplified. So 150 over 100 is the same as 3/2, right? So in this case, don't worry, we will go to we'll go back to the previous example. So in this case, right, I'm going to express it as fractions because I have an unknown. So 2/7, okay, remember it's the ratio of blue over pink, right? 2/7. Now, I know that there are 16 blue marbles, and they want to know how many marbles are in total. Now, remember the blue plus the pink is going to be equal to the total. Now, I don't know the pink. However, I can express it within the same ratio. So this is the simplest ratio. This guy is the ratio. And this is the actual. Now, remember, the fractional expression, if we express it as a fraction, is going to be equal. The ratio and the actual amount is going to be equal in ratio. So I could express this as 16 divided by an unknown pink amount. An unknown pink amount. And actually, I've created an equation. Okay, why have I created an equation? Because I know that 2/7 is definitely equal to 16 over something. Why? Because the ratio remains constant, right? Remember, this 2:7 is the simplest ratio. The simplest ratio. And then 16 is to something would be the actual amount. So 2:7 would be the same ratio as 16 is to the pink amount that we have missing, right? It could even be 20. We could calculate if we had 20 blue marbles, how many pink marbles we had. We could also calculate if we had 14 pink, how many blue do we have? Okay, because it's maintaining the same ratio, we understand that the change that was made to the blue is the same change that's going to be made to the pink. So 2 ways of approaching this. Second way is going to be better. Let's look at the first, right? So to get from 2 to 16, that's how we can firstly try to understand it. To get from 2 to 16, again, because remember the ratios remain constant, right? If they're going to tell us that the ratios of blue to pink marbles is 2:7, why would it change? Okay, it's always going to be 2:7. For every 2 marbles of blue that we have, we would get 7 pink marbles. Okay, so technically you could also consider how many 2s do we have in 16 and then multiply that by 7, because for each 2 we have 7. Okay, but let's not take long ways, but let's just first understand this, right? So to get from 2 to 16, we multiply by 8. Okay, the ratio remains constant. So if you want to know how many pink marbles we have when we have 16 blue, we have to multiply by the same value as well, 8. Okay, so now in that case, then we can simply say that the pink marbles are going to be 7 times 8, which is 56, I think, if my timetables have not left me. Okay, so that's understanding purposes. Mathematically speaking, we create a ratio. 2/7 is equal to 16 over an unknown pink amount of marbles. Okay, it's an unknown value that's represented by X. You could represent it with any variable, P, Q, R, S, T, V. I was just using pink, P because it's pink, X because that's the first one we use in maths, Y, second one, right? That's just, right? So I have 2/7 is equal to 16 over X. In this case, I do what we call cross multiplication, where I multiply 2 by X, 2X, and I equate it to the multiplication of 6 and 16 and 7. Okay, so you don't have to do it, but it's fine. 16 times 7, we're going to get a value of 112. 2x, divide both sides by 2. X is going to give us a value of 56 as well. So we get the same value. Okay, second way is just the best mathematical way to approach it. First way is an understanding approach. Okay, so again, don't be scared if you see questions backwards, right? You know the formula, you know how to work forwards. Always write out something, okay, as if you're working like a regular question, right, where they give you both initial informations, and then equate it to whatever they give you. So, okay, in this case, it's slightly different because we're not dealing with like algebraic equations, but again, we know the concept. So yeah, it's just utilizing, it's utilizing the concept of using fractions as ratios, which are the same. Okay, I just want to quickly go through this one more time. Let's get rid of everything and just go through it entirely, right? I think people understand that. Okay, so firstly, right, share 69 apples between horses, pigs, and goats on a farm in the ratio 15:5:3. Now, we need to calculate the total amount of parts. So or let's call it shares. So this guy gets 15 shares, 5 shares, 3 shares. So in total, we have 23 parts or shares. Okay, so 23 parts, and then we can easily distribute. Okay, you get 15, you get 5, you get 3. Okay, so in this specific case, right, for horses, let's say, out of the 23 parts, they need to take 15. So we create a ratio. If I'm not mistaken, we did fractions not so long ago, I'm not sure if we did it or we did it at the grade 9s. Calculating percentages, maybe we did it at the grade 9s. But we always want to take whatever our amount is, right, divided by the total amount, which in this case is 23. Okay, so that's how I create the fraction. For pigs, I will say their amount divided by the total amount. We're talking about ratios, right? The share. Goats, I will say their amount divided by the total amount. So that's how I'm creating this fraction, right? Taking this ratio, dividing it by basically the total ratio when I add them all up, and I'm multiplying it by the total. So this is basically giving me a calculation that's going to get me the value, okay, of the share of horses, because they need 15 shares out of 23. So 15 out of 23, if I take that fraction and calculate what is the value of 15 out of 23 of 69. Okay, it's almost like, just say I would like to know what is 1/3 of 69. Okay, what are 2/5 of 69? Okay, these are, remember, these are like multiplication of fractions. Okay, calculating a portion of a whole number, right? Let's do an easier one. Let's say I want to calculate what are 2/5 of 10. Okay, so remember, let's see, 2/5 of 10. How many 5s are there in 10? There's 2 5s, right? 1, 2, 3, 4, 5, 6, 8, 9, 10. 1, 2, 3, 4, and 5. So if I take 2 of these, all right, that's going to give me, if I just take these 2, it's going to give me a total of 4, 1, 2, 3, 4 over the entire thing, right? So 4 parts out of 5 in total. Sorry, 2. 1, 2, 3, 4, 4, and 5. So I've separated into 5 parts. So I have to take these first 2 to make it 2 over 5, right? But if I want to get it as 10, I consider all the numbers, it's actually going to be 4 over 10. And you'll notice, of course, the ratio here is maintained either way, multiplied both by 2. Okay, so that's an explanation for these fractions. Okay, then I multiplied out each answer and I get a value of, I'll tell you for each one, 45, 15, and 9. Okay, each the amount of apples that each animal gets. Okay, let's move on to rate. Okay, remember these videos will be uploaded, so if you are still confused about something, you feel you are free to watch them again until you understand them. Okay, remember, if you guys do have any questions, please let me know in the chat or the Q&A or the YouTube chat. Okay, rate is a way of comparing two different quantities. Okay, so let's have a look at what they mean by that. I think when we did ratio, we defined ratio as a way of comparing two of the same quantities. Right, remember we converted each one to the same unit, okay, and we compared two of the same quantities. Now with the rate, we are comparing two different quantities, right? So now, express each of these as a rate. Okay, if you think of the word rate in English, okay, it explains it in maths. We always consider the rate at which you're doing, but the rate at which you are doing something, right? Basically, like the speed at which you are doing something. Are you doing something fast? Are you doing something slow? How fast are you doing something? Okay, if you're packing the dishes, how many plates are you packing per minute? Okay, we could describe something like that as a rate. Okay, that's why we are comparing two different quantities. So if we look at our first example, 5 kg of chicken for 179.99 Rand. So we have two different quantities. We have weight, we have currency, an amount, right, of value in rands, money. So the way we can express this, okay, is we could calculate the rate as what would it cost per kg? Okay, how much are we paying per kg? That's a rate. Okay, we could say for 1 rand, how many kgs are we getting? Okay, that's a bit more what's the word? It's not the best way to describe this rate, okay, but it's possible as well, right? Instead, we would calculate how many rands per kg. That would be the better one. Okay, so remember the word per refers to division. Okay, so if we want to say how many rand per kg, we're going to say rand per kg, right? So basically rand per division kg. Okay, rand divided by the kg is going to give us the rate of rand per kg. Per refers to divide. That's why I've put the division line there. All right, rand per kg. Put in, geez. Okay, so in this case, I have 179 rand 99, and I'm going to see per 5. In this case, it's 5 kg because that's the price of 5 kgs, and this is going to give me the value, the rate of chicken per kg. All right. Also, if you want to understand it, you can see that this division is actually taking 179 and separating it into 5 equal parts. All right. So in that case, that makes sense because for 479 rand 99, we're getting 5 kgs. So if I just divide that by 5, it's going to give me the value of 1 kg. Right. So when we do that calculation, I'm just going to round it off. We actually get an answer of around 36 rand, okay, per kg. Okay, just for this one, I just want to do, if we wanted to calculate how many kilograms per rand do we get? How many kilograms of chicken do we actually get per rand? Maybe you have 2 rand to spend, even though they're not going to sell you chicken for 2 rand. Just for interest sakes, how much kg would they give us if we had 1 rand, 2 rand, whatever, right? So if I want to calculate for the same value, I want to calculate the kg per rand value, the amount of kgs I'm getting per rand. Okay. Yes, of course, I would then say 5 over 179.99. And I get an answer of kgs per rand, basically 0.0278 kgs per rand or per 1 rand, because a rand, 1 rand, same thing. Okay, so you're going to get, if you had to convert it to grams, you're going to get about 27.8 grams of chicken. The calculation is showing 35.998. Okay, so let me not do this. Am I wrong if you say 35.99? Because that's the answer I got when I calculated. Okay, you guys are 100% correct, right? What you want to do is you want to always, actually, no, I'm 100% correct. Never mind. You always want to, okay, is it possible to round off to the amount of rands? Okay, let me answer this question, right? So generally, you guys want to get into the habit of rounding off to 2 decimal places from now, okay? Some of you might have teachers who specifically want you to round off to a certain amount of decimals, or maybe they want you to round off to the nearest rand. Please listen to your teacher accordingly, right? However, if you don't have any instructions, you can round off to 2 decimal places. Do not round off to the nearest rand. It might be too far off. Remember, sometimes in the memo for certain questions, they have an error margin. So if your answer is close to the answer, they'll give you the mark. Okay, but sometimes it can't be too far away, right? It has to be like really close, or they have a certain amount that they allow past the answer and a certain amount before the answer. So 2 decimal places is the safest bet. So in this case, you actually get 35.998. If you want, you can leave it. You technically actually rands, you should round off to 2 decimal places. Why? Because cents, right? Remember, we work with cents, which only has cents go up to 99 cents, and then 100 cents make 1 rand. Okay, so 2 decimal places. So in this case, remember, 2 decimal places, we want to round off there. We have to look at the third number. When we look at the third number, it's bigger than 5, so it's actually going to round that number off. So the 9 is going to change to a 0. It's going to round the next number off. So that's also going to change to 0, and it's going to round the next number off, because 9s always pass over to the next number. So this actually does round off to 36 rand. So here, and put 0.00 so that you're seeing 2 decimal places. So here we are not rounding off to the nearest rand. We are rounding off to 36 point. We're rounding off to the 2 decimal places, which actually then gives us 36. But if I said 35.99, would I get math wrong? Most likely not. Okay, you could get a teacher who's really fussy. That's for you to judge, but most likely not. You would most likely get that correct. Okay, let's move on. Let's look at this. Traveling at 275 kilometers in 2.5 hours. Could somebody tell me in like a statement where I'm saying kilometers per hour, hours per kilometer, what would be the best way to express this as a rate? Just tell me what the unit / the other unit. What would be the best way to express this as a rate? Okay, good, correct. Kilometers per hour, distance per time, that's more like the what do we call this? Whatever it is, but remember, these are units, right? Kilometers per hour, not kilometers per minute, because they've given us in hours. Okay, so it's better to do it in kilometers per hour. Okay, so remember, we want to express it in kilometers per hour. So we are going to say 275 divided by 2,5. Okay, we get an answer of 110, and my unit is going to be what? What is this rate? This rate is in kilometers per hour, or H, doesn't it matter? Kilometers per hour. So that's my unit. So this is basically now telling me, right, that I am going to travel if 110 kilometers per hour. So if we had to consider, they travel 275 kilometers in 2.5 hours. So they were traveling approximately at a speed of 110 kilometers per hour. Let's look at this example. Which deal is cheaper? 30 milk chocolate bar. Let's see. I just need to think which example we need to do. You guys can address this question on your own. 30 milk chocolate bars for 270, or 42 mint chocolate bars for 320. So here I would suggest you calculate the value of each milk or each chocolate bar. Okay, and that would tell you which deal is cheaper. If you're getting the price per chocolate bar, if you're able to express it, because you can't compare the price of 30 and 42 chocolates respectively. It doesn't make sense, right? You're not going to be able to tell which one is more expensive. But now if you reduce it to the price of 1 chocolate bar and 1 mint bar, then you can compare them, right? So do that. A car travels an average of 90 kilometers per hour. How far will it travel in 2.5 hours? Okay, so this would be like distance, speed, time. I'm not sure if we've done those formulas, but essentially could be how far. Okay, this is just, I would say, more of a logical approach, but you guys can attempt that. Let's look at this last one, right? The temperature of water in a kettle. 1 second. Okay, the temperature of water in a kettle increasing at a rate of 15 degrees Celsius per minute. How long will it take the water to boil if the temperature of the water poured into the kettle at 20 degrees? If the temperature of the water poured into the kettle is 20 degrees Celsius. Okay, let's look at this rate that's given to us. 15 degrees per minute. So expressed mathematically, we could say 15 degrees Celsius per minute. Okay, so every minute it's going to be increasing by 15 degrees Celsius. So in 2 minutes, it's going to be increasing double that, right? So 15 times 2. In 2 minutes, it will increase by 30 degrees Celsius. How long will it take the water to boil if the temperature of the water poured into the kettle is 20 degrees Celsius? So the water is already at 20 degrees Celsius. It's starting value, right? At what temperature does water boil? Someone tell me. At what temperature does water boil? Do we not know? 30, 100, 100. Okay, 100 is indeed correct. Water freezes at 0. Okay. 30, not on Earth at least. Triangle. Okay, we'll go through that. Actually, like I'm not sure if we should. The section does not involve. We don't have to utilize that. It was just a possibility for you to utilize it. It's more like of a physics, just distance equations. I would rather just use the logic of rate to calculate that. Similarly, like how we're going to do this question, you would do the previous question. Okay, so 100%, you guys are correct, right? So water boils at 100 degrees Celsius. So from 20 degrees Celsius, we need to get to 100 degrees Celsius. Okay, so basically it's going to be a difference. We need to increase our temperature by 80 degrees. Okay, so they are asking essentially, how long would it take to increase? What is no? What are you referring now to? How long would it take? How long would it take to increase 80 degrees? Okay, so two ways to approach this. The first is that we know that it's increasing at the rate of 15 degrees Celsius. Okay, so 15 degrees per minute. So remember Celsius, degrees Celsius actually, per minute is equal to 15 over 1 minute. And now I can equate this to actually what I want to increase it by. So I want to increase this to 80 in an X amount of minutes. So we've created the mathematical equation. I understand that this is the rate expressed as like a ratio, okay, like a fraction. Degrees Celsius in 1 minute, 15 in 1 minute. So I want to know how long will 80 take. I can cross multiply. And I get 15x is equal to 80. And essentially 80 divided by 15 will give me the answer. Okay. Logical explanation. If in 1 minute I increase 15 degrees, okay, if I want to calculate how long would it take to increase 80 degrees Celsius, I could say how many 15s are in 80, okay? How many times can 15 fit into 80? That's going to tell me, okay, in that amount of minutes, that's how long it's going to take you to increase to 80. So basically it's going to be X is 5.33 minutes. That's how long it would take to increase by 80 degrees. That's how long it would take for the water to boil, since we started on a temperature of 20 degrees Celsius. Okay, so attempt these on your own. Let's move on, right? Let's start finance at least so we can get the basics down. Just real quick, please tell me quickly, what are you guys currently busy with in school? Common fractions is my guess. Exponents. Okay, exponents is a bit ahead. Some people are still in HCF, LCM. Okay, mixture. Seems like we're in the middle, finance, simple interest, etc. A lot of people are percentages, integers, Quran. Okay. Okay, fractions. Okay, cool. So we like sort of in the middle of everyone. Okay, so for those people ahead, that's good. For those people who are behind, we'll get there. Okay, fractions, exponents, and integers. Okay, some people are very ahead. Okay, percentages, right? Let's look at this. So before we do finance, we're just going to revise some percentage concepts, right? We're not going to go through all examples because the formulas are here. So percentages, percentage means per 100. This is revision from work done in grade 7, of course. Okay, per 100, remember, divided by 100, essentially what it means. So when we talk about 73%, we are talking about 73 divided by 100. So this is also like a ratio. Okay, because out of 100 parts, we have maybe 73 parts. Okay, so 73 over 100, and this can also be, you can calculate the percentage of another number. So let's do this example. So it says calculate 35% of 700. So 35% of 700, we say that, did we do this already? We didn't? Can I just get everyone to just confirm with me if you remember if we did this? Okay, perfect. So when we say 35% of 100, we're going to say 35 over 100 to convert that to that, right? Remember, okay, so we said per 100, per means division. We have another word, or of is multiplication, okay? So 35% of 700, we're going to say 35 over 100 multiplied by 700. Okay, multiplication of fractions, we're probably still going to get there. However, for those of you that can use a calculator, you can use a calculator from this step. For those of you that cannot, you are going to convert 700 into a fraction, okay, by dividing it by 1. Let's just... okay, let's just do this, 700. We're going to have 35 over 100 multiplied by 700 over 1. Convert both to a fractions. Now, you'll see when we do multiplication of fractions, when you multiply fractions, you always just multiply in a straight line. Numerator by numerator, denominator by denominator. These are big numbers, so we can utilize our simplification method of crossing out values or simplifying values, dividing values by the highest common factor, one in the numerator, one in the denominator, right? So any numerator and any denominator. So the first one I can see is 100. I can divide 100 by 100 and I get 1, and I can divide 700 by 100 and I get 7. Okay, so that's cross simplification. Okay, I can divide anything in the numerator and I can divide anything in the denominator, right? In this case, I'm left with 35 times 7, which that can be calculated, 245. What are we dealing with? So the value of what is 35% of 700 Rand? It's going to be 245 Rand. Let's do this example. What percentage? Okay, let's do it. Yeah, let's do it. Okay, I'd like to do one more of these. Let's just say you're writing an exam out of 75 marks and you achieve 80%, right? So your teacher gives you your mark, 80% of 75. So your teacher gives you a mark and she just gives it to you as a percentage, and you want to know actually how many questions did I get right? How many marks did I specifically lose? So you can calculate that simply by utilizing this. You're going to say 80% of 75, which is the marks of your exam. Then you're going to convert percentage. So 80 over 100, of is multiply 75 over 1. Again, those who have the calculators can simplify from here. So what can I do? I can simplify 75 maybe and 100. So maybe I'll take 1010. So basically I'm dividing both by 10. Remember, any numerator, any denominator. So I divide 80 by 10 and I divide 100 by 10. I get 8 and 10 respectively. Then I divide 10 by 5. I get 2. And when I divide 75 by 5, I get 15. Okay, actually I can divide 8 and 2 again. 8 I can divide by 4. Sorry, I can divide 8 by 2 and I get 4, and 2 I can divide by that, I get 1. Now I just have simply 4 times 15, which is going to tell me 60. 60. So 80% of 75 is 60. So basically you got 60 out of 75, which again, same ratio gave you 80 over 100, which is 80%. Okay, let's have a look at this one. Why do you divide by 5? Okay, because 5 is a number that goes into both. So 80 over 100 multiplied by 75 over 1. Okay, so I can simplify any number in the numerator with any number in the denominator. So for example, I could simplify 80 and 1. I could simplify 75 and 100. I could simplify 80 and 100. I could simplify 75 and 1. Okay, any number in the numerator with any number in the denominator, provided that I can find a number that can go into both. We are essentially doing highest common factor. We are finding a common factor that can go into both just to simplify our calculation, right? Instead of saying 80, because remember, you multiply in a straight line, right? When we do the multiplication, you can't say 80 times 75. These are high numbers, right? If you are doing it without a calculator, and 100 times 1, right? That's very complicated. So in order to simplify it, we can simplify on top or simplify at the bottom. So in this case, again, I can divide both of these by the same number. There is a common factor between 80 and 100. I can divide 80 by 10 and I get 8. I can divide 100 by, we can even simplify completely further. If I divide them by 20, let me just try to think. Maybe this time let's divide 175 completely. So I need to find a number that can go into 175. Again, you don't have to, in this case, you don't have to choose the highest, even if you choose any number, just to simplify it step by step, like I did here. Okay, so I know that I can divide both of these by 5 to simplify it. So when I divide 100 by 5, I get 20. When I divide this guy by 5, I get 15, I think. Yeah. Okay, so now I have it simplified. Now let's look at 80 and 20. I can divide both of these by 20. When I divide 20 by 20, I get 1. When I divide 80 by 20, I get 4. Okay, so all we are doing is we are simplifying these numbers by dividing them by the exact same value. In this case, now I'm left with, what am I left with? I'm left with 4 over 1 times 15 over 1. Okay, we'll do a lot more examples of this when we do multiplication of fractions. Okay, let's just quickly go through this example. What percentage of 126, sorry, what percentage is 126 out of 210? Okay, this is similar to the Mark story. Okay, so you want to know, out of 210 Rand, I have 126. So what percentage of the way am I to 210? Maybe you are saving up for to get 210 Rand and you currently have to 126 Rand. So you want to know what percentage have I saved up yet, right? So in that case, you always want to put your denominator as the total amount, which in this case is 210 Rand. In your numerator, you're going to have what amount you currently have. Okay, just similarly with your marks, you put your mark over the total possible marks. Okay, it might be 75, might be 80, right? And you're going to multiply it by 100. That's always the step to convert it to a percentage. Here we have it represented in a fraction, multiply it by 100 to get it as a percentage. Time is class end, normally at 50, we should end at around 53. Let's just try and complete a few things. So 126 over 210 multiplied by 100, that gives me 60%. So I've done it on a calculator. Remember, you can do it both ways, right? At this point, I'm not sure if you guys should be having, but you guys really should be having calculators at this point, right? Should be allowed to use calculators for certain things. If a theater can seat 260 people, what percentage of the theater would be occupied if 104 seats are occupied? So again, remember, we want to put our total at the bottom. So the total amount of possible seatings we have is 260. Then we want to calculate the percentage occupied. So we have the number of people that are occupying seats. The number of people that are occupying seats is 104. We take this number, that's this fraction that we just created, and multiply it by 100 to always be able to convert it to a percentage. Okay, I'm going to simplify this. I'm going to divide both of these by 10, because remember, it is technically 100 over 1. Divide this by 10, I get 26. Divide this by 10, I get 50. I can divide both of these by 2. When I divide 104 by 2, I get 52. When I divide this by 2, I get 13. And it doesn't make our life any easier, to be honest, but I just put it in the calculator. So that's what I'm saying. At this point, you guys should be allowed calculators because of weird calculations like this, right? And I get an answer of 40%. Okay, let's end it there. Okay, and we will continue increasing or decreasing by a percentage next week, move on to percentage increase or decrease, profit or loss, and eventually simple interest. Okay, so yes, hopefully next week we are not allowed to use a calculator. Okay, again, if you're not allowed to use your calculator, you're going to utilize this method. Okay, when we do simplification of fractions, addition, subtraction, multiplication, division of fractions, it's going to become easier. All right, but again, you want to utilize this method where you convert everything to a fraction, simplify a numerator and a denominator by dividing each one by the same denominator, right? Just do one at a time. Choose one numerator and one denominator. If you can divide them by the same number, attempt it to simplify your numbers, okay, so that it's easier to do the multiplication. Okay, just double check with your teacher if you are allowed a calculator, like one more time. Okay, hopefully next week we will get to simple interest, higher purchase loan, and exchange rates. Let's try and do everything. We allowed to use calculators during tests. That's crazy. That is not crazy. Okay, you are in high school, I think, at this point. So it's not so much about what the calculator can do for you. It's about what you can do with the calculator, because it gets, at this point, it's difficult. The work is a lot more difficult. So the calculator is just there to aid you. It's kind of crazy, yes, maybe because you have not, you've been using a calculator since time. Okay, thank you guys so much for joining. I will see you guys next week again, where we'll continue finance. Okay, all the best for you guys' school week. And yeah, cool. Jazakallah for attending. Okay, that makes sense. Geen probleem. Okay. Assalamu alaikum.